Absolute value inequalities. Before we begin, let's look at some simple examples. Suppose we have an absolute value that is less than a positive number. For instance, the absolute value of x is less than positive 5. Let's start with a number line. When we look at the number line, we can see that all the numbers whose absolute value is less than 5 will be numbers less than positive 5. But also will be all the negative numbers that are greater than negative 5. The numbers whose absolute value are less than 5 are the numbers between negative 5 and 5. This is called a conjunction and is written negative 5 is less than x is less than 5. Now let's look if we have an absolute value bigger than positive 5. Once again, look at the number line. In this case, all the numbers whose absolute value is bigger than 5 will be the positive numbers bigger than 5, but also the negative numbers less than negative 5. This is called a disjunction and is written with the word or. We write x is greater than 5 or x is less than negative 5. There are also two special cases. In the first case, we have an absolute value less than a negative number. This is impossible, so we have no solution. The other special case is when the absolute value is bigger than a negative number. Well, all absolute values are bigger than negative numbers, so that's all real numbers. These are our basic principles. Now let's look at some actual examples. Example 1 is the absolute value of x minus 4 is less than 3. This is called a conjunction because the absolute value is less than a positive number. Write the x minus 4 in the center, make it less than 3 and greater than negative 3. Solve this compound inequality by adding 4 to both sides. This gives us x is less than 7 and greater than 1. This is our solution. To graph our solution, put a 7 and a 1 on the number line. Mark them both with a hollow circle and color in between the two numbers. Now pause the video and try the next example yourself. Now that you have tried it, check your work. This is also a conjunction. Write the 2 plus 3x in the center. It is less than or equal to 7, but at the same time greater than or equal to negative 7. Begin solving by subtracting 2 from all three parts. This gives us negative 9 is less than or equal to 3x, which is less than or equal to 5. Now divide all three parts by 3. This gives us x is less than or equal to 5/3 and at the same time greater than or equal to negative 3. To graph our solution, decide approximately where to put negative 3 and draw a solid circle, and where to put 5/3 and draw a solid circle. Color in between the two circles, and this is our solution. In example 3, the absolute value is not isolated yet. To isolate it, we need to divide both sides by negative 7. This will reverse the inequality, so it faces the other way, and we get the absolute value of 3x minus 4 is less than positive 13. Since it is less than a positive number, we have a conjunction. Write 3x minus 4 in the center. It is less than positive 13 and greater than negative 13. To begin solving this, add 4 to all three sections. This gives us 3x is less than 17 and greater than negative 9. Now divide all three sections by 3. This gives us x is greater than negative 3 and less than 17/3. This is our solution. In order to graph the solution, we need to find approximately where 17/3 is on the number line. Draw a hollow circle at negative 3 and another one at 17/3. Color in the graph between the two circles. This is the graph of our solution. In example 4, once again, we need to divide to isolate the absolute value. We get 2x minus 4 is less than negative 10, since dividing by negative 3 reversed the inequality. We now have an absolute value is less than a negative number. An absolute value can never be less than a negative number. This is impossible. Since it is impossible, this is a no solutions. Whenever you have an absolute value less than a negative number, it will be no solution. Now let's look at disjunctions. Whenever you see an absolute value greater than a positive number, you have a disjunction. Whenever you have a disjunction, start with the word or. Write the inequality just as it appears, except without the absolute value. So negative 5x is greater than or equal to 15. On the right side, write the negative 5x again, but this time it should be less than or equal to negative 15. Now solve both inequalities. On the left, divide by negative 5. This will reverse the inequality, giving us x is less than or equal to negative 3. Divide again by negative 5 and reverse the inequality, giving us x is greater than or equal to positive 3. Our result then is x is less than or equal to negative 3, or x is greater than or equal to 3. Draw two solid circles and make sure the arrows point away from each other. The solution to a disjunction will always have the arrows pointing away from each other. Now pause the video and try the next example yourself. Now that you have tried it, check your work. First, notice that you have a disjunction. This means you start with the word or. Write on the left, 8x minus 6 is greater than 7. On the right, repeat the 8x minus 6, but put less than negative 7. Solve both inequalities. Start by adding 6 to both sides of the inequality, giving us 8x is greater than 13. Now divide both sides by 8, for x is greater than 13/8. On the other inequality, start by adding 6 to both sides. This gives us 8x is less than negative 1. Now divide both sides by 8, for x is less than negative 1/8. Our solution then is x is greater than 13/8 or x is less than negative 1/8. Draw a hollow circle at the negative 1/8 and draw the arrow going to the left. Put the positive number to the right, draw a hollow circle, and draw the arrow going to the right. This is our solution. In example 8, we need to start by isolating the absolute value. Do this by dividing both sides by negative 2. This reverses the inequality and gives us our absolute value is greater than a positive 5. Thus we have a disjunction. Write an or problem. X plus 8 is greater than 5, or x plus 8 is less than negative 5. Solve both inequalities by subtracting 8 on both sides, giving us x is greater than negative 3, or x is less than negative 13. Draw a hollow circle at negative 13 and an arrow going to the left. Draw a hollow circle at negative 3 and an arrow going to the right. Our solution is x is greater than negative 3, or x is less than negative 13. Now let's look at example 8. Once again, isolate the absolute value, giving us an absolute value is greater than negative 22. Whenever we have an absolute value that is greater than a negative number, our solution is all real numbers. Color in the entire number line. Please refer back to these notes often as you complete your homework. Thank you.